Hi everyone, it's Kira Garfolo with Greenville Tech Math 155. Today we're going to talk about section 4.5, which is volume and capacity. So what is volume? You've probably talked about it in a science class before. And basically volume is just how much space it occupies. If you think about a liquid or a fluid, it's how much you could pour into there. Okay, so it's how much space, three-dimensional, an area occupies. Like we did for area, we had the 2 dimensions that we were multiplying together. For volume, we're going to multiply 3 dimensions together. So our units will be cubed. Similar to how we had area being squared units, we're going to have cubed units. We may have centimeters cubed, inches cubed, etc. Okay? Now, before you calculate, just like we saw for area, just like we saw for perimeter, make sure that all of the measurements are converted to be the same units if necessary. If they're not given all as centimeters, then convert them all to centimeters or whatever you want to convert everything to. They all need to be the same units for this to work. Like I said, with area and perimeter, it's very difficult, if not impossible, to undo that if you do the calculations beforehand. So you'd need to go back and recalculate. So sometimes rather than having those cubed units, we're going to have designated capacity units. They exist in both the English system and the metric system, okay? It's still, technically speaking, it's still the amount of space taken up, but it's different than what we consider volume, okay? In our English units, the most common capacity units are ounce, fluid ounce, okay? So not like mass ounce. Fluid ounce, pint, quart, gallon, barrel, etc. Okay, so these are things that you know count how much of something you have, but we're not talking about a cube unit. In the metric system, the capacity standard is liter. So from there you can go to milliliter, centiliter, kiloliter, etc. Okay. Something that's very important to remember is that 1 centimeters cubed is the same as 1 cc. You can think about cc being centimeters cubed, okay? That's where it comes from. And that's also equal to 1 milliliter, okay? So 1 centimeter cubed is 1 cc is 1 milliliter. Let's talk about some volume here. Remember that a prism from section 1 is a solid figure with the top and the bottom surface parallel to each other, okay? And they have to be the same size and shape. So that means that the sides of our prism have to be parallelograms. The volume for a prism is going to be the volume equals base times height, but be careful here. B is not simply just one measurement from the base. It is the area of the base, and H is that vertical height. Remember, it's the vertical height, not necessarily the diagonal again, okay? So another way to think about this is the area of the base times its vertical height, okay? Now remember, these formulas are going to be given to you on the test in your formula sheet, but again, be absolutely sure that you're familiar with that formula sheet so that you know what is given and what format it's given, where to find it quickly, things like that. Let's look at an example. We want to find the volume of this prism, okay? We're going to note that the base is a rectangle, okay, because we have a right angle there. It doesn't look like it because 3D drawings are weird, but we're going to have 14 inches and 16 inches on our base, okay? And the height here is 30 inches. This 34 inches here is irrelevant, okay? It's extra information that we don't actually need for this problem. Remember, we want the vertical height. So the area of our base is going to be the area of this little rectangle right here. So its area is going to be 14 times 16, which is going to give us 224 inches squared, okay? And the height is 30 inches. So if we multiply all of that together, we're going to get 6720 cubed inches. Now, some of you in other classes might have learned that volume is length times width times height for a prism like this. That works too, because notice that this is just the area of the base. So if you want to think about it like that, go for it. It's the same thing. Now you take a moment and try this. Find the volume of this prism. Pause, work it out, and then resume. So the area of our base is going to be, because this is 35 also, 35 inches times 12 inches. And the vertical height is going to be 30 inches. So our volume is going to be 35 times 12 times 30, which if we punch into a calculator is going to give us 12,600 inches cubed. Okay. Now, some of you might work this one out first and then multiply it by 30. Remember, that's fine. You can do it all together. You can separate them. Multiplication doesn't really matter. Just make sure that you can get that final answer. Now, another shape that we talked about was a cylinder. And remember that a cylinder has a top and a bottom that are a circle. And then we have kind of that tube that goes up from there. And if we're finding the volume for a cylinder, we're going to follow the exact same method that we just used for the prism. The only thing is that our area of our base now is the area of a circle. Okay. You can also think about this is pi r squared times h, because that's going to be your area. Okay. Some of you may have learned it that way in another science class. So let's look at this example. If we want to find the volume of this cylinder here, remember that the top and the bottom are circles and then they have to be parallel. Okay. So that means that they're not angled one way or another. That means that they will never touch each other. So we know that our circles have a diameter of 60 centimeters and the vertical height is 50 centimeters. This here is irrelevant. It's not the vertical height. We don't need it for this problem, okay? The area of our base is going to be pi r squared. Remember that our diameter is 60, so that means our radius must be 30 because it has to be half of that, okay? So that's where we get this. So pi r squared is our area. Our height is that vertical 50 centimeters. Putting it all together, pi times 30 squared times that height of 50 is going to give us 141,372 cubic centimeters. Okay, now you pause and give this one a try. This one's on its side, but still works the same way. If you want to draw it upright, you certainly can. I'm not an artist. This is going to be 9, and this is going to be 15, okay? And they're meters. So remember that our volume is going to be the area of the base, or the area of that circle, times the height. The area of that circle is going to be pi times r squared. So if our diameter is 9 meters, then our radius must be 4.5 meters. Okay. So we're going to have pi times 4.5 meters squared. So that's pi r squared. And our height is going to be that 15 meters. So if we plug all of this into our calculator, we are going to get about 954.3 meters cubed. Okay. Now the volume of a pyramid is kind of similar to the area. You can kind of sort of relate it to a triangle, right? Where a pyramid has those triangular edges. The volume here is going to be 1/3 times the area of your base times your height. Okay. So you're going to do it very similarly to the way that you do it for one of those prisms, but you're going to multiply it times 1/3. Okay. If we want to find the volume of this pyramid, let's list what we know. We know that our height is 75 centimeters. And we know that our base is actually a square. Okay. So the area of our base has to be 50 centimeters times 50 centimeters. So our volume has to be 1/3 times that area of base times our height. So it's going to be 1/3 times 50 centimeters times 50 centimeters times our vertical height of 75 centimeters. Plug all of this very carefully into our calculator, and we are going to get 62,500 centimeters cubed. Okay. These are fairly straightforward if you know what you're looking for and what you're looking at. Certainly get some practice here. I would say the number one mistake on tests is when you see that formula being V equals 1/3 base times height. The number one mistake is that this is actually the area of the base, not just one of the measurements. Definitely the easiest mistake that I see. Now, the volume of a cone works just like the volume of a pyramid, except remember now we have a circle as our base. So we're going to find the area of that base for the circle, and then we're going to multiply it times 1/3 times that height. Okay. So remember the area of a circle is going to be that pi r squared. So your volume here, is going to be 1/3 times pi r squared times your height. Okay. Now the volume of a sphere. Remember that a sphere is a ball. Okay. It's just that perfectly circle, round, marble, ball, whatever you want to think of, the globe. The volume per sphere is calculated as the volume equals 4/3 times pi r cubed. Again, that formula will be given to you, so don't worry about memorizing it. But you can see that it also has a cubic element because we're talking about 3 dimensions. So for example, if we wanted to calculate the volume of this sphere, remember that we need 4/3 times pi times r cubed. This is our diameter. So our radius has to be 30 centimeters because it's half of the diameter. And so if we just plug this into our formula, we get 4/3 times pi times that 30 centimeters cubed. And so our final answer is 113.97 cubic centimeters. Please, please, please make sure that you can replicate these in your own work. Go ahead and pause and take a moment and solve this one. The volume of this sphere. Remember what we need volume is 4/3 pi r cubed. We know that r here has to be 40 inches, okay, because this is the diameter. So our volume is going to be 4/3 times pi times 40 inches cubed, which if we plug this into our calculator, we're going to get 268.82.6-ish inches cubed. Okay. If you aren't able to get these examples, you need to pause, you need to go back, you need to use whatever resources in your text or anywhere else to get it, because I do ask questions just like these on the test, and they're pretty easy if you know what you're looking at. But, you know, if you don't, you're going to miss a lot of questions and a lot of points, and you don't want to do that at the end of the course. Now, sometimes we want to combine our formulas, okay? Just like we saw with area, just like we saw with perimeter. Sometimes we don't have just a standard shape. We don't have just a sphere or just a cone or just a pyramid, okay? To do that, we will need to combine multiple volumes, okay? So looking here at the snow cone, we can see that we have a hemisphere here, okay? And then we have a cone. We need to find the volume of the cone and the volume of a hemisphere and add them together. We didn't talk about the volume for a hemisphere, but you know that it's half of a sphere. So you're going to take half of the volume of the sphere. The cone's volume, remember, is 1/3 times the area of that base times the height. Its height is 9 centimeters. Its area of the base is going to be pi r squared. So there's your pi, and your radius is 4 because the whole diameter is 8. Okay. So your cone has a volume of 151 centimeters cubed. Man. Okay. Your hemisphere has a volume of 1/2 of the volume of a sphere. So the volume of that whole sphere is 4/3 pi r cubed. So a half of that, we're going to get 134 cubic centimeters. So that means the volume of the entire snow cone has to be that 151 plus 134, which is going to give us 285 centimeters cubed. Okay. So we're just going to add the 2 here. Okay. Now, just like we had to convert area units, we can convert volume units. We thought it blew up fast with area, and it blows up even faster with volume. Okay. So set up the conversions just like before. Remember, if we're starting kilometers into meters, it's easiest to say, okay, you have 3 kilometers cubed is 3 times 1 kilometer times 1 kilometer times 1 kilometer, which is what we see here. And then convert each of these individual one-dimensional kilometers to meters. Plug it into your calculator and multiply it out. Okay. This is going to give you, what, 3 billion meters cubed? Blows up pretty fast, right? What about 200 millimeters cubed into decimeters cubed? Well, remember that millimeter is 10 to the negative 3, and decimeter is 10 to the negative 1. So you're going to move that decimal place 2 because 3 to 1. Okay, and we're going to a bigger one, so we're going to move it left. So you're going to have 200 times 1 millimeter times 1 millimeter times 1 millimeter, and each of those becomes 0.01 decimeters. Working this out here, you're going to get 0.0002 decimeters cubed. Okay. Lastly, change 5 feet cubed into inches cubed. This works the same even though we don't have the metric system. 5 feet cubed is the same as 5 times 1 foot times 1 foot times 1 foot, and each foot is 12 inches. So you're going to get 8640. Now you give it a try. 5 kilometers cubed into meters cubed. This is a great place to pause and work it yourself. So we start by saying, okay, wait, 5 times 1 kilometer times 1 kilometer times 1 kilometer. And if we want to convert each of these into meters, 1 kilometer is 1,000 meters times 1,000 meters times 1,000 meters. And if we plug this into our calculator, it is going to give us, it might give it 5 times 10 to the 9th meters cubed, which is going to be 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So 5 billion meters cubed. Okay. 50 millimeters cubed in decimeters cubed. We have 50 times 1 millimeter times 1 millimeter times 1 millimeter. So that's going to be 50. Remember that 1 millimeter, that's 10 to the negative 3, 10 to the negative 1. So we know that 1 millimeter equals 0.01 decimeters, because we're going to go 1, 2. Okay. So this is going to be 0.01 decimeter, 0.01 decimeter, 0.01 decimeter. And plugging that into our calculator, you're going to get 0.00005 decimeters cubed. Or if you plug it into your calculator, and sometimes it'll give it to you automatically, it's going to be 5 times 10 to the negative 5 decimeters cubed. Okay. Make sure that you can do these too. So in conclusion, there are a lot of real world applications for volume, probably even more than we have for area. Okay. If you have questions, you need to get them answered, whether that's emailing me, talking to the Math Center. Always go back and look in your textbook, work through the example problems, work the extra problems at the end of each section. There's a review section where you can get more. There's a lot of extra stuff. Remember, there's also supplemental instruction materials that are given out. There are video recordings, other lectures, things like that. Make sure that you get the help that you need. You definitely need to practice these, okay? We only have one section left in this unit, which is the last section for our entire course. So make sure these are all building on top of each other. So if you need to get help, you need to get it now. Don't bomb your last test of the semester, okay? Remember that some of our usual units are actually capacity units, but if we're talking about volume, we're going to be talking about cubed units. And I'll mention that in the next section also, but it's important to, if you're asked what kind of unit it is, if you're trying to determine if it's capacity or volume, for the volume, just look for the cubed, okay, for our course. If you're talking about volume, look for cubed. Again, practice, practice, practice. If you have any questions, certainly reach out. I'm happy to help. Lots of resources available at your disposal. Okay. Thanks as always for tuning in, and I'll see you next time for our last section.